and we're going to talk about some ions and also some nomenclature in this portion. A says main group atoms gain or lose electrons to get the same number of electrons as the nearest noble gas. Main group atoms are going to be the taller columns or groups on the periodic table. Metals lose electrons to become cations. Non-metals gain electrons to become anions, where anions are negatively charged ions and cations are positively charged. And so with two main group atoms, let's see how this works. If we have a sulfur and we have a sulfur on the periodic table, we can see that sulfur is element number 16. That sulfur has 16 protons and 16 electrons for an atom. So this is going to be a sulfur and it's going to be an atom. And so it's going to have 16 electrons. From there, we see that the nearest noble gas is going to be argon. And argon, in order to have the same number of electrons as argon, which would be 18 electrons, sulfur must gain 2 more electrons. And when it gains 2 electrons, it gains a 2 minus charge, electrons being negative, and a sulfur 2 minus has 18 electrons. And 2 minus is the charge on a sulfide ion, and that is the name of that. Whereas we had a sulfur atom, where sulfur is the name of the element, the ion is called the sulfide. And what we will see is that all of the nonmetals form monatomic ions, where mono means one and atomic means atom. So this is a monatomic ion because it's made out of one atom, and they all end in IDE for the nonmetals. Now let's go to a metal, sodium atom. On the periodic table, it's element number 11, so it will have 11 protons and 11 electrons. Now, all right, let's show the whole periodic table here. Good. Here's sodium. Its closest noble gas is actually one element behind it, Ne, neon. Sodium atom has 11 electrons. It must lose 1 electron to have the same electrons as neon. So sodium loses 1 electron to become sodium plus. Now it has 10 electrons, which is the same number as neon. And the name of this is going to be and this is true for all of the metal ions, it's going to have the name of the element. It's just the sodium ion. So metals just have the name of the ion, of the element, whereas non-metals have sort of the root of the element ending in IDE. Now let's talk about the transition metals. And for the transition metals, actually we don't want to do that, good. For the transition metals, things will be a little different because, as I mentioned before, transition metals can oftentimes form more than one and almost always 2 ions. Let's look at iron. Iron can form a +2, and iron can form a +3, or a 3+, if you will. And again, I don't care if you write it +2 or 2+, +3 or 3+. Typically, it's written 2+ or 3+. And so now, first off, we cannot use that rule about the nearest noble gases. It gets a little more complicated, and we'll talk about that more later in the course. And the other thing is, these two ions have different names, nomenclature-wise. This is going to be iron with the charge in Roman numerals, in capital Roman numerals. In parentheses, and that's the charge. And it may or may not be the number of iron 2 ions in the compound. Oftentimes it's not, actually. This will be iron 3. And my suggestion is that you memorize these names and memorize which ions are possible, because again, this will help you, like now any nomenclature helps you think about chemistry even when you're not doing nomenclature. Bromine and strontium are going to be companion problems to write out this type of reaction, or the type of reaction that we did on the previous page. Or not a reaction, but to think about what is the nearest noble gas and how many electrons it needs. Now, this is going to be, for polyatomic ions, straight memorization of nomenclature. And I'm going to list a few of the most important ones to memorize. One of those is going to be ammonium ion. And it will be important to be able to tell ammonium from ammonia, where ammonia, also important to memorize, not an ion, just a compound, or a molecule, if you will. Then some common negatively charged, or anions, will be hydroxide, nitrate, sulfate, that's 2 minus, and carbonate. And you're right, if you think it's a common ion and it tends to have an ATE ending, you are right. Now, there are other trends for things called the oxoanions. If you remember, one of them, such as phosphate or sulfate, we just talked about sulfate, we actually just talked about nitrate as well. And as you move from sulfate, if you memorize that, if you take away 1 oxygen, so less oxygens, take away 1, you go to sulfite. Nitrate, different charge than sulfate, but again, the same process. If you take away 1 oxygen, you go from nitrate to nitrite. If you take away another oxygen, if that's even possible, and it is for if there are oxoanions with chlorine. And the term oxoanion just means there are oxygens as part of the anion. Anyway, you can go from chlorite to hypochlorite and chlorate to perchlorate. And these are the most common examples of this as well, and you will find some other examples too. Again, good to memorize, good to be familiar with what these formulas are, good to know their charges as well.